Europa is a moon of Jupiter, about the size of Earth's moon, which has an icy surface that probably hides a subsurface ocean.
The three main things that we're going to explore at Europa are the ice and the ocean and understand that intersection between the two.
Europa is the sixth largest moon known for its icy surface, deep, hidden ocean, smooth, cracked ice, and strange moving patterns shaped by Jupiter's gravity. However, after exploration, scientists think something may be living beneath its frozen ice, a discovery that is making Europa one of the most mysterious worlds studied. This is not a random idea, but something far stranger than we first thought. How can a moon without air or weather hold the possibility of life deep inside? Join us as we uncover the secrets behind this discovery. Europa, the frozen moon with a hidden ocean. Far away from Earth, moving around the giant planet Jupiter, there is a mysterious moon called Europa. At first glance, Europa looks cold, silent, and completely frozen. Its bright, icy surface sheens in the darkness of space, making it appear calm and lifeless. But beneath that thick, frozen shell, scientists believe something extraordinary may exist. Hidden deep below the ice could be a massive ocean of liquid water. Europa is slightly smaller than Earth's moon. It is a little more than 3,100 kilometers wide, making it one of the larger moons in the solar system. Even though it is the smallest of Jupiter's four famous Galilean moons, Europa has become one of the most important places scientists study today. Scientists believe Europa is made mostly of silicate rock, similar to the rocky planets closer to the Sun. Deep inside the moon, there may also be a metallic iron core. This means Europa is not simply a frozen ball of ice. It is a layered world, with rock, metal, ice, and possibly a giant ocean hidden underneath. The most fascinating part of Europa is believed to be its enormous water layer. Scientists estimate that this layer may be around 100 kilometers thick.
Jupiter, the giant of our solar system, is a world of awe-inspiring beauty and scientific marvel.
The upper part is frozen into solid ice, while the lower part may exist as a huge liquid ocean beneath the surface. This hidden ocean may contain more water than all the oceans on Earth combined. Some scientists believe Europa's ocean could hold 2 or even 3 times more water than Earth. Because water is considered one of the most important things needed for life, Europa has become one of the most exciting places in the search for life beyond Earth. Even though Europa is extremely cold, the ocean beneath the ice may remain liquid because of powerful forces created by Jupiter's gravity. Europa does not move around Jupiter in a perfect circle. As it travels, Jupiter constantly pulls and stretches the moon. This stretching creates heat deep inside Europa, helping to prevent the underground ocean from freezing solid. Europa's surface temperature is unbelievably cold. Around the middle areas of the moon, temperatures average about 160 degrees below 0 Celsius. Near the poles, the temperatures become even colder. The ice covering the moon is believed to be as hard as granite rock on Earth. Scientists became more confident about the hidden ocean after information was collected by the Galileo spacecraft. The spacecraft detected signs of a magnetic field around Europa. Researchers believe this magnetic field may be caused by a layer of salty liquid water beneath the icy crust. The surface of Europa is also filled with strange markings, cracks, ridges, and broken regions called chaos terrain. These areas look as though giant pieces of ice broke apart, shifted around, and then froze again. Some scientists believe warmer ice or water from below may have pushed upward and changed the surface. Researchers still debate how thick Europa's icy shell truly is. Some scientists support the thick ice model, which suggests the crust may be between 10 and 30 kilometers thick. Others support the thin ice model, which suggests some areas could be much thinner. If the ice is thin, the hidden ocean may sometimes come close to the surface through cracks and openings. In the year 2026, research suggested that Europa's seafloor may be quieter than scientists once believed. Computer models showed that the rocky layer beneath the ocean might now be too strong to crack under Jupiter's tidal forces. This could reduce the amount of chemical energy available deep below the ocean. But what if the smooth, frozen surface of Europa is not empty at all, but hiding moving ice, shifting cracks, and secret water deep below? Europa's frozen surface and the strange secrets beneath the ice. Among all the worlds in the solar system, Europa stands out as one of the strangest and most beautiful. Its frozen surface looks calm from far away, but scientists believe powerful activity is happening beneath the ice. Europa is known as the smoothest object ever discovered in the solar system. Unlike many moons and planets covered with giant mountains, deep valleys, and countless craters, Europa's surface appears surprisingly flat and young. Very few craters can be seen on Europa. Scientists believe this is because the moon's surface is constantly changing. Old marks disappear as new ice and movement reshape the crust. This active surface makes Europa look fresh compared to many older worlds in space. The ice covering Europa also reflects a large amount of sunlight, making the moon one of the brightest moons ever observed. Researchers estimate that Europa's surface may be between 20 million and 180 million years old. In space terms, that is considered very young. One possible feature that fascinates scientists is the idea of giant icy spikes near Europa's equator. These spikes are called penitentes. Some researchers believe they may rise as high as 15 meters above the surface. Scientists think they could form because sunlight strikes the ice directly near the equator, causing parts of the ice to slowly turn into gas. Over time, this process may create deep cracks and tall, sharp structures across the frozen ground. Although spacecraft images have not fully confirmed these icy spikes, radar and heat information collected from Europa support the possibility that they exist. The most famous features on Europa are the dark lines stretching across the moon's surface. These lines cross over each other in every direction, covering nearly the entire world. Scientists call these features lineae. Some of them are extremely large, stretching for great distances across the ice. The biggest bands are more than 20 kilometers wide. When scientists studied these dark lines closely, they discovered something surprising. The icy crust on opposite sides of the cracks appears to have shifted and moved apart over time. Researchers believe warm ice from below may have pushed upward as the crust slowly opened. This process may be similar to the way Earth's ocean floors spread apart deep underwater. Scientists think Jupiter's gravity plays a major role in creating these fractures. Europa always keeps nearly the same side facing Jupiter. As the moon travels around the giant planet, Jupiter's powerful gravity constantly pulls and stretches Europa's icy shell. This repeated movement places stress on the crust and may cause many of the cracks covering the surface. Some researchers also believe Europa's outer ice shell may rotate slightly faster than the deeper layers inside the moon. This may happen because a hidden ocean beneath the ice separates the surface from the rocky interior below. Studies suggest that one complete movement of the outer shell compared to the inside may take at least 12,000 years. Images from spacecraft have also revealed signs that Europa may experience a form of plate movement similar to Earth's tectonic plates. Some sections of the icy crust appear to spread apart, while others seem to push together and sink below the surface. This suggests Europa's crust may slowly recycle itself over time. Europa's surface also contains strange round and oval features called lenticulae. These features appear in many forms. Some look like domes rising upward. Others appear as dark spots, pits, or rough, broken regions. Scientists believe some of these features may form when warmer ice rises upward through colder ice near the surface. In certain places, melted water may break through the crust and create darker regions. The roughest areas are known as chaos terrain because the surface looks broken into countless icy blocks floating in frozen material. Another idea suggests that some of these strange shapes may simply be smaller chaos regions that looked unusual because early spacecraft images were not very clear. In the year 2011, Researchers presented evidence suggesting that many chaos regions may sit above large lakes of liquid water trapped inside the ice shell. These lakes would remain completely enclosed within the frozen crust, above the deeper ocean below. Some scientists also believe certain chaos regions may have formed when comets crashed through Europa's icy surface and reached the hidden ocean underneath. If there is no real air, no wind, and no weather, how can a moon still have an atmosphere at all? And what does this thin, invisible layer reveal about the hidden world beneath Europa's ice? Europa's thin atmosphere. Far away in the deep darkness of space, orbiting the giant planet Jupiter, lies a frozen world called Europa. At first sight, it looks like a quiet ball of ice with no air and no life. But when scientists looked closer, they discovered something surprising. Europa does have a very thin atmosphere, so thin that it is almost invisible. This fragile layer is not like Earth's air. It is light, weak, and constantly changing. Europa's atmosphere is made mostly of oxygen, with small traces of water vapor. But this oxygen is not created by living things. Instead, it is formed in a very unusual way. The surface of Europa is covered in ice. When sunlight and strong charged particles from Jupiter hit this icy surface, they break the water molecules apart. This process creates oxygen and hydrogen. The hydrogen is extremely light, so it escapes into space. The oxygen stays behind for a longer time, forming a thin layer around the moon. This process is called radiation braking, where energy from space slowly changes the surface of Europa. Because of this, the atmosphere is always being rebuilt again and again. It is never stable. It forms, breaks, and reforms in a constant cycle. Even though it is thin, this oxygen layer can rise as high as 190 kilometers above the surface. That is very high for such a small and icy moon. But even at that height, the atmosphere is still extremely light compared to Earth. One interesting fact is that Europa is one of the few moons in the solar system that has a measurable atmosphere. Along with other special moons like Titan, Io, Triton, Ganymede, and Callisto, Europa stands out as a world where gases can still be detected, even if they are extremely thin. Because oxygen stays longer on Europa's surface than hydrogen, it slowly builds up a very faint atmosphere. But this atmosphere does not behave like Earth's. There are no clouds, no wind, and no rain. The gravity on Europa is too weak to hold a thick atmosphere. It is only about 13% of Earth's gravity, which is not strong enough to keep heavy air around the moon. Even without weather, Europa is not completely still. Scientists believe it is geologically active. Tiny amounts of oxygen and hydrogen are constantly being released into space. This means the moon is always breathing in a slow and quiet way. Because of this constant loss, the atmosphere must always be renewed from the icy surface below. Europa also has a small magnetic field created by interaction with Jupiter's powerful magnetic environment. This magnetic field changes in size as Europa moves around Jupiter. This behavior suggests that something inside Europa is conducting electricity. Scientists believe the most likely reason is a large salty ocean hidden beneath the ice. Some of the oxygen created on the surface does not escape into space. Instead, part of it may be absorbed back into the ice. Scientists think this oxygen could slowly move downward into the deeper layers. If the icy crust connects in any way with the hidden ocean below, this oxygen might eventually reach the water. If that happens, it could play an important role in chemical reactions inside the ocean. Europa also forms a faint ring of particles along its orbit around Jupiter. This ring is made from the slow release of oxygen and hydrogen. It creates a thin cloud of neutral particles that spreads along Europa's path in space. Space missions have detected this cloud, confirming that Europa is constantly losing small amounts of material. Even though this gas cloud exists, Europa still does not have real weather. There is no sky color, no clouds, and no changing atmosphere like Earth. The environment is silent and extreme. Temperatures on the surface can drop to about 160 degrees below 0 Celsius at the equator, and even lower at the poles. The ice remains frozen solid all the time. But deep below this frozen surface, scientists believe a different world exists. The hidden ocean beneath the ice may have temperatures close to 0 degrees Celsius. Because of internal heat created by gravity and motion inside the moon, parts of the ocean may stay warm enough to remain liquid. Over billions of years, this ocean may have changed from a more acidic mixture into a salt-rich sea, similar in some ways to Earth's oceans. Europa's thin atmosphere may seem weak and fragile, but it tells an important story. It shows that even in the coldest and most distant places, chemical processes are still active. The moon is not completely still. It is slowly interacting with space, with radiation, and with its giant planet Jupiter. What if a frozen moon is not still at all, but constantly being stretched, pulled, and heated by the invisible grip of a giant planet? The moon, shaped by Jupiter's hidden forces. Far out in the solar system, there is a frozen moon called Europa. It moves around the giant planet Jupiter in a steady and quiet path. One full journey around Jupiter takes about 3.5 days. Even though this sounds fast, Europa is very far away from its planet, at a distance of about 670,000 kilometers. Its path around Jupiter is almost a perfect circle, with only a tiny change in shape. This makes its motion very smooth and stable. Europa does not spin freely like Earth. Instead, it is locked in place by Jupiter's gravity. This means one side of Europa always faces Jupiter. From that side, Jupiter would always appear fixed in the sky, hanging in the same position without moving. Because of this, scientists say Europa has a special point on its surface that always looks toward Jupiter. There are signs that Europa may not always spin in a perfect way. Some research suggests that in the past, or even slowly today, Europa might rotate slightly faster than its orbit. This idea points to something important hidden inside the moon. It suggests that the icy outer shell may not be fully attached to the rocky interior. Instead, there may be a layer of liquid water in between that allows movement. Europa's orbit is not completely fixed. It is slightly stretched and shaped by the gravity of Jupiter and nearby moons. This small change in shape is very important. As Europa moves closer to Jupiter, the planet's gravity becomes stronger. It pulls the moon, stretching it slightly like soft clay being pulled in opposite directions. When Europa moves farther away, this pull becomes weaker, and the moon slowly returns to its round shape. This constant stretching and relaxing creates tides inside Europa, not in oceans seen on the surface, but deep inside a hidden ocean. These tides act like a slow kneading force, heating the inside of the moon. This heat may be one of the main reasons the underground ocean does not freeze. Without it, the ocean would likely become solid ice. The source of this energy begins with Jupiter itself. Jupiter spins very fast, and its gravity creates tides on its moons. One of these moons transfers energy to another through a chain of orbital connections. In this way, energy slowly moves from one moon to another, finally reaching Europa. This process keeps Europa active from the inside, even though its surface looks cold and still. Scientists have studied long cracks that cross Europa's surface. These cracks act like a record of the moon's past movements. They show that the surface has been pulled, bent, and broken many times. Some evidence suggests that Europa may have once been tilted on its side. If this is true, it would change how scientists understand its surface features. A tilt in Europa's position would create different patterns of stress across the ice. This means the cracks we see today may have formed in different directions over time. It also suggests that the surface of Europa may be younger than once thought, because new cracks could form more often if the tilt changes the way forces act on the ice. The icy shell must constantly adjust to these movements. When stress builds up too much, the ice breaks. These breaks form long lines and fractures across the surface. If Europa's tilt changed in the past, it may have created stronger heating inside the moon. More heat would keep the ocean beneath the ice liquid for longer periods of time. This idea also affects how scientists estimate the age of Europa's ocean. If the tilt caused more heating, then the ocean may have stayed liquid for a longer time than earlier models suggested. This increases the chance that the ocean has remained stable for a very long period. However, scientists are still not sure when or if this tilt happened. It remains one of the many mysteries surrounding Europa. What is clear is that the moon is not a simple frozen ball. It is a world shaped by powerful gravity, hidden motion, and constant internal energy. What could be hiding beneath Europa's frozen surface after billions of years in darkness? Let's take a look at what scientists discovered when they finally got close. The scientific mission to Europa's frozen ocean world. For many years, Europa has fascinated scientists around the world. Long before spacecraft traveled to Jupiter, researchers already believed Europa might contain large amounts of water. By the beginning of the 20th century, gravitational studies suggested the moon was rich in water materials. Later, in the year 1957, Earth-based observations by astronomer Gerard Kuiper confirmed that Europa's surface was covered in water ice. Human exploration of Europa truly began during the 1970s. The spacecraft Pioneer 10 and Pioneer 11 flew past Jupiter in the years 1973 and 1974. They captured the first close images of Europa, although the pictures were not very clear. A few years later, the Voyager spacecraft changed everything. In the year 1979, both Voyager probes traveled through Jupiter's system and captured far more detailed images of Europa's frozen surface. Scientists noticed strange cracks and lines across the ice. These discoveries led many researchers to believe a liquid ocean might exist beneath the surface. The biggest breakthrough came with the Galileo spacecraft. Starting in the year 1995, Galileo orbited Jupiter for 8 years and studied the giant planet and its moons in great detail. During many close flybys of Europa, Galileo collected valuable information about the moon's icy crust, magnetic field, and hidden ocean. These discoveries made Europa one of the most important places in the search for life beyond Earth. In the year 2007, the spacecraft New Horizons also captured images of Europa while traveling through the Jupiter system on its journey toward Pluto. Later, in the year 2022, the Juno spacecraft flew only a few hundred kilometers above Europa's surface, giving scientists another close look at the mysterious moon. Interest in Europa continued to grow. In the year 2012, the European Space Agency selected a mission called Jupiter Icy Moons Explorer, also known as JUICE. The spacecraft launched in the year 2023 and is expected to reach Jupiter in the year 2031 after a long journey through space. Meanwhile, NASA continued developing plans for Europa exploration. Scientists proposed missions that could fly past the moon, orbit it, or even land on its frozen surface. One of the most important projects became Europa Clipper. The mission was designed to study Europa's chemistry, ice shell, and hidden ocean. The spacecraft would orbit Jupiter and perform many close flybys of Europa.
Excited about the potential to unlock the secrets of Europa, the potential to really understand this crazy world.
Instead of directly orbiting the moon itself, Europa Clipper launched in the year 2024 aboard a Falcon Heavy rocket. During its mission, the spacecraft is expected to make dozens of low-altitude passes above Europa. It carries powerful instruments, including radar systems that can look beneath the ice and cameras that can study the surface in detail. Scientists are especially interested in Europa because of the possibility that life might exist beneath the frozen crust. Many future mission ideas focus on exploring the underground ocean directly. Some concepts include underwater vehicles that could swim beneath the ice. Others involve special melting machines called cryobots that could slowly melt through the thick frozen shell. However, Europa is also extremely dangerous for spacecraft. The Moon sits deep inside Jupiter's powerful radiation environment. Any robotic mission sent there must survive intense radiation every single day. Researchers also discovered another possible challenge. Studies suggest Europa's surface may contain tall, sharp ice spikes that could make landing very difficult. Even with these dangers, scientists continue searching for ways to explore this frozen world. But what if one of the coldest places in the solar system is not empty at all, but quietly hiding the right conditions for life deep beneath its ice? The possibility of life on Europa. On the icy moon called Europa, scientists have not yet found any proof of life. But even without direct evidence, Europa has become one of the strongest candidates for possible habitability in the solar system. This means it may have the right conditions for life to exist, even if life itself has not been seen. The most important reason for this hope is the hidden ocean beneath the ice. Scientists believe Europa has a deep layer of liquid water under its frozen surface. On Earth, life is often found in places where water, heat, and chemicals come together. One example is the deep ocean near hydrothermal vents, where warm water rises from below the sea floor and supports strange living creatures even in total darkness. Scientists think similar environments could exist in Europa's hidden ocean. Even if Europa does not have volcanic activity like Earth, energy may still be produced in other ways. Studies suggest that reactions between water and rocks beneath the ocean could create hydrogen. At the same time, radiation on the surface may produce oxygen and other compounds. These materials could slowly move into the ocean below through cracks and shifting ice. This combination of elements could provide chemical energy that simple life forms might use. In some studies, scientists have also found evidence that salt from the underground ocean may have reached the surface. This suggests that the ocean is not completely sealed off. Instead, it may be interacting with the rocky layer below. If water and rock are in contact, important chemical reactions could take place over long periods of time. This increases the possibility that Europa might support life. One of the strongest forces inside Europa is tidal heating. As Jupiter's moon Europa orbits, tidal forces from the planet stretch and heat its interior. Scientists think this heating may keep a subsurface ocean liquid and drive movement in ice and rock. This raises the possibility of life in several environments, such as near the ocean floor, around vents, beneath the ice, or drifting in the ocean. On Earth, organisms survive in extreme places, suggesting similar life could adapt there. However, conditions may be too harsh, with cold or salinity limiting life to simple forms. Radiation on the surface may also create compounds that could provide energy for basic life. In this way, the surface and the ocean may be connected in a slow but important cycle. But later observations have suggested that oxygen levels on the surface might be lower than once thought, which changes how scientists understand this process. There is also the possibility that Europa contains smaller hidden lakes within the ice itself. These lakes would not be part of the main ocean, but would still contain liquid water trapped inside the icy shell. Some regions on the surface show signs that water may have once moved upward, frozen, and created strange icy shapes. If these hidden pockets exist, they could also be places where life might survive. Another idea suggests that Europa's surface may contain materials like hydrogen peroxide. On Earth, when hydrogen peroxide mixes with water, it breaks down and releases oxygen. This could provide energy for very simple life forms. However, scientists are still studying how much of these materials exist on Europa. Even with all these possibilities, newer research suggests that Europa's seafloor today may be quieter than once believed. The rocky layer beneath the ocean may not be very active at present. This means there may be fewer strong chemical reactions happening at the bottom of the ocean. Without these reactions, the energy available for life could be limited. Scientists now think that if habitable conditions exist, they may depend more on slow chemical processes rather than active geological movement. Another interesting idea is that Europa's surface contains clay-like minerals. On Earth, such minerals are often linked with organic materials. These minerals may have arrived after impacts from space rocks or comets. Some scientists even suggest that life from Earth could have been carried through space and landed on moons like Europa. This idea remains a possibility, but has not been proven. In the distant future, Europa itself will change again. As the sun grows older, it will expand into a red giant. During this time, Europa may warm up. Its ice could melt and form a temporary global ocean. This ocean would not last forever, but it could exist for a short time. During this period, conditions might briefly become more suitable for life to develop or grow. After that stage, the water would slowly disappear into space, and Europa would return to a frozen state once again. Through all these possibilities, Europa remains a world full of questions. It is a frozen moon with a hidden ocean, unknown chemistry, and possible energy sources. Even without confirmed life, it continues to be one of the most exciting places in the search for answers about life beyond Earth. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.